Hello students. Today we are going to be going over solving multi-step inequalities. So you'll need to be taking notes right now. And basically you solve multi-step inequalities about the same as equations, except you have to switch the direction of the inequality if A, you use the reflexive property. If you have 15 is less than X, it becomes X is greater than 15. So we did a flip-flop, and when we switch them, we have to switch the sign. See how it was less than here, and now it's greater than over there. So that's one time where you would flip the sign. The next way is if you multiply or divide by a negative number on both sides of the inequality. For example, negative 5x is greater than 10. We divide by negative 5 on both sides, then we have to switch the sign. We still go 10 divided by negative 5 is negative 2, and we still have x, and then we switch the sign from greater than to less than there. Or if you have x divided by negative 3 is less than or equal to 5, what you would have to do is multiply that by negative 3 and this by negative 3. So then your solution would be, cancel that out, x, instead of less than or equal to, it becomes greater than or equal to negative 15. And there you would have your answer. So again, x greater than or equal to negative 15. And hopefully you can see that okay. All right. So I'm going to go ahead and do a few problems. Hopefully I gave you enough time to write this down. If not, we can pause the video. We'll do a few problems from the homework now. Okay, so number 1, negative 6x plus 7 is less than or equal to x plus 7. So we always want to draw a line down the inequality sign, just like we did with the equations, and I'm going to actually make a T here. So you have that T. So the first thing we want to do is get all the numbers on the same side, so I'm going to go minus 7, minus 7. Now, do we switch the inequality sign? And the answer is no. We didn't do any of those three things. So we get negative 6x, these go away, that goes away, is less than or equal to x. Okay, now we want all the x's on the same side, so I'm going to go minus x, which I probably should have done this one first. Negative 7x less than or equal to x minus x. Some of you might get confused here and think it's no solution, and that's wrong because x minus x is 0. Then I asked myself, did I need to change the sign? No, because I didn't multiply or divide by a negative number, and I didn't switch anything as far as the reflexive property. So this is negative 7 times x. I'm going to divide by negative 7. So x is less than or equal to, oh wait, I divided by a negative number, so it's not less than or equal to, is it? Greater than or equal to 0. Okay, then we're going to graph that on the number line. We're also going to put it in interval notation. So here's 0. I usually like 3 numbers on a number line. So is it an open or closed dot? I look at this. This takes more ink or equal to. So this is going to take more ink. So it's colored in and it's greater than. So that's arrows going to the right. When I have my variable on the left side, this goes to the right. Okay, interval notation. Our lowest number is 0. And does it include 0? Yes, so it's a bracket. And it goes on to forever, infinity, which would be parentheses, because infinity is always parentheses. And we're done with that one. Okay, let me go on to the next one. Let's go on to number 4. First thing we want to do is multiply and use the distributive property. Leave this 5r plus 38. Oh, I forgot my t. That's my bad. It's greater than 5r, because I'm using the distributive property, plus 30. Going to still draw my t. Now I want to get all the r's on the same side. Oh, they go away, and they go away. What's left? 38 is greater than 30. Now remember what happened when you got rid of the variable disappeared on the equations? We checked to see if it was a true statement first. Is 38 greater than 30? Is that true or not? If it's true, then yes, you write true. And what's the solution if it's true? Infinitely many solutions. Okay, how do I graph that on a number line? I might put 0, 1, -1. And infinitely many, that means anything that I can have on this number line is going to be a true statement. Okay? And how do I do that in interval notation? I'm going to go lowest number is negative infinity. It goes all the way up to positive infinity. And then I'm done with that one. So you need those three things: infinitely many solutions, the number line colored in, and negative infinity, comma, positive infinity. Now, if this had not been a true statement, if it was false, then it would be empty set. And remember, empty set looks like this, just so you know the notation for empty set. Okay, we would leave the number line blank and write the word empty set or put that symbol so we know, hey, we've done the problem, it shows empty set. Now we'll go and do one more problem on the back that's a little more challenging. Okay. So just because it's longer doesn't mean it's any harder. Okay, so the first thing I want to do is draw my line down here. Okay, and that's very important, especially for a problem like this. We have negative x minus 2x all on the same side. Let's combine them, and that'll be negative 3x. Now I'm going to put a 1 in front of there because it's just a lonely little negative by itself. Put a 1, and I'm going to distribute this through the parentheses. So even though I'm multiplying by a negative number, because I'm not doing it to both sides, I will not be changing the sign. So I go negative 1 times 4x is negative 4x. Negative 1 times negative 7 is plus 7. Plus, I'm going to also distribute this negative, or this 6. 6 times negative x is negative 6x. 6 times 7 is 42. And I have that problem there. Okay, now I see like terms all on the same side. Some of you are going to make a mistake and try and go plus 6x plus 6x. You do not want to do that. You want to say, hey, here's my 4x. I'm going to box these because they're the same and I can combine them. And I'm going to circle these so I can combine them as well, all on the same side of the equation. So we do not change the signs. Okay, so negative 4x and negative 6x, I combine them and get negative 10x. I combine 7 and 42 and I get plus 49. And I still have my lonely negative 3x over here. Now I want to get negative 10x to this side, so I'm going to add 10x here, add 10x here. Negative 3x plus 10x is 7x, and I'm going to put greater than 49. Okay, I never had to change the sign again throughout this whole thing. I didn't divide or multiply by a negative or do the reflexive property. Now I'm going to divide by 7, and x is greater than 7. Okay, if I do that on a number line over here, 7, 6, 8. Now I ask myself, open or close dot? There's no or equal to, so I don't include 7, so that's an open dot. And which way do I shade? This arrow's going to the right. I want to keep a good habit of keeping the variable on the left side if I can, because this arrow will point like, hey, that's the direction you want to go ahead and shade. What is it in interval notation now? The lowest number is 7, and it's not included. And then it goes on to infinity. And infinity is always a parenthesis and never in a bracket. Okay? All right. I think you can finish the rest on your own. Have fun. You rock, students.